Jai Hind to all. My name is Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Akgec, Engineering College, Ghaziabad. Today, in this video lecture, we will learn about the disk scheduling algorithm. So, this is the table of content outline that I will discuss in this lecture. Actually, there are different type of disk scheduling algorithms like FCFS, SSTF, scan, C-scan, look and C-look. So, the concept of each type of disk scheduling algorithms will be discussed in this lecture, and we will also solve some type of problem based on each type of disk scheduling algorithm. So, let us start with the introduction of the disk scheduling algorithm. What is disk scheduling algorithm? Actually, it is actually a process during its life cycle. A process remain in two cycle. First one, it is busy with the input output cycle, and second one, it is busy with the CPU cycle. It means whenever it is under the executions of the CPU. So, whenever a process requires some kind of input output, so that input output request is basically performed on the disk, on the hard disk. Okay, so whenever input operation means we are going to write something on the hard disk, and output operation means we are going to access some stored data on the hard disk. So this is that is known as the input output request on the hard disk. Okay, so suppose this is a queue for the several input output requests, then in which order these input output requests will be executed, or in which order these input output requests will be serviced. So that decision is carried out with the help of disk scheduling algorithm. It means disk scheduling algorithms helps the operating system to decide the order of execution or order of service for the various input output requests submitted in a queue. So that is the use of disk scheduling algorithm. Let us start with the first algorithm, FCFS. FCFS disk scheduling algorithm. In case of FCFS disk scheduling algorithm, that input output requests which come first in the queue, that will be serviced first. This is the basic concept of the FCFS disk scheduling algorithm. For example, suppose we have a queue of input output requests. This is this is a queue of the input output, and we have the requests like 98, 183, 37, 122, 14, 124, 65 and 67. So these are the input output requests submitted in a queue, and the current head position is the 53, and there are 200 tracks in the hard disk. Okay, so since there are 200 tracks, so these tracks will be numbered from 0 to 199. 0 will be the innermost track and 199 will be the outmost track. Total there are 200 tracks on the hard disk. Okay, and current position of the hard disk of the read write head, this is the actually question. This is the input output queue of input output request, and there are 200 queue numbered from 0 to 199, and current head position is given 53. Now in this algorithm we have to calculate the total head movement. In each type of algorithm, we have to compute the total head movement. Total head movement. And sometimes this is also known as the total distance or total seek time. So either total head movement or total seek time or total distance traversed by the read write head. To solve such type of problem, different disk scheduling algorithms are used. So this is the queue of input output requests. So at first we will mention all the input output requests along a line, and this is the innermost track 0, this is the outermost track 199, and we have mentioned here the current position of the read write head, and all the input output requests are mentioned in increasing order. So let's start. So in case of FCFS disk scheduling algorithm, the input output requests which come first, that will be serviced first. Okay, so at first the input output request 98 is submitted in the queue. So from current position 53, read write head will move to the 98, and it will service the request 98. After that it will go to the next request. Next request is 183. So 183 will be executed. After 183, next request is 37. So after servicing the request for the track number 183, the read write head will move to the request number 37 and it will service the 37, and after 37 it will move to the request to the track number 122 and it will service the request of 122. After that, request number input output request for the track number 14. So from 122 it will go to the track number 14 and it will service the request input output request. After that, from track number 14 it will move to 124, track number 124, and service the request of track number 124. After that, 65 and then 66. So in this case, when we calculate the total, so this is the total movement of the read write head. Now we have to calculate this total movement. So this will be, how we will calculate it? This will be what? 98 minus total head movement, 98 minus 53 plus this distance. This distance is 98 minus 53. Now this distance will be 183 minus 98. 183 minus 98 plus again this distance 183 minus what is this? 37. Okay, plus from 37 it moves to the 122. So 122 minus 37 plus from 122 again it moved to the 14. 122 minus 14 plus from 14 it moved to 124 again. So 124 minus 14 plus from 124 minus 65 and again 67 minus 65. So in this way total head movement will be calculated. Okay. So this is the concept of the FCFS. Next CPU scheduling, disk scheduling algorithm is the SSTF. SSTF is also known as the shortest seek time first. In this case, from the current position, the read write head will move to the to service the input output request, which will be near to its. Okay. So whenever the position of the read write head will change, then at a particular instant of time, the read write head will execute that input output request which will be nearest to its current location. This is the concept of the shortest seek time first disk scheduling. For example, again here this is the queue of the input output request. So this 0 is the innermost track and 199 is the outermost track, and current head position is 53. Okay. So in this input output request which is nearest to 53. So nearest to 53 is the 65. So at first the read write head will move from 53 to 65. Again after 65 the nearest input output request is 67. So it will execute the 67. After executing the 67, again the nearest request of 67 is 37. So it will service the request 37. Again from 37 the nearest input output request is 14. So it will go to 14, track number 14, and service the input output request 14. After that from 14 the remaining request are these 98, 183, 122. So from 14 nearest request is 98. So it will move to the 98 and service the request. After 98 it will move to 122 because 122 is more nearest to the 98. After 122 it will go to 124, and after 124 it will go to 183. So in this way the read write head of the disk will execute all the input output requests submitted in the queue. And when we will calculate the total head movement, again 65 minus 53 plus 67 minus 65 plus 67 minus 37. So in this way when we will add, then total head movement will be 236. So this is the concept of the shortest seek time first disk scheduling algorithm. Next, this is the third disk scheduling algorithm. This is known as the scan disk scheduling. Sometimes it is also known as the elevator disk scheduling algorithm. What happen in this case? The read write head will move to the current position, from current position to a particular direction. Either it is scan, see scan, look and see look. To solve the problem based on these algorithm, at first we have to know the movement direction of the read write head. It means in which direction read write head is moving. Either it is moving in increasing order of track, or it is moving for the decreasing order of track, or we can say that it is moving in the left direction or right direction. So once the directions of the read write head, movement of the read write head is known to us, after that we will apply the concept of scan disk scheduling. And in case of scan disk scheduling, the read write head will move from its current position either in increasing direction or decreasing direction, and it will move to the again this is the queue of input output request, and 53 is the current position. So here the direction of read write head is the left direction. Read write head is moving in left direction, or it is moving in decreasing order of track. So at first read write head will move to the left, and it will service all the requests coming in the path. So when read write head will move from current position to the left direction, then at first this request number 37 is encountered. So it will execute the request number 37. After that, when it will move to left, then request number 14 will occur in the path. Then it will service the request number 14. Again, since 0 is not a request, but in case of scan disk scheduling, after executing or after servicing the last request in a particular direction, it will move to the end. Okay, so it will move to the innermost track 0. From 0, read write head will reverse its direction, and again it will move to the last request, and it will service all the remaining requests coming in the path. So when it will change its direction from 0 and move in this direction, then after that the remaining at first the remaining request is 65. So it will execute the request 65. After that, again it will execute the request of track number 67. After that, again when it will move to right, then it will service the request of track 98. Then it will service the request of track number 122. Then it will service the request of track number 124, and after that it will service the last request 183. So in case of scan disk scheduling, the read write head in which direction it is moving, it will go to the last track in that particular direction. For example, here it was moving in the left direction. So after completing the last request, it will go to the last end or last track 0. Again it will change its direction and move in that direction and service all the remaining requests, and it will stop when the final request is executed. It will not go to this end. Okay, so in this way the scan disk scheduling algorithm work. Again, when we will calculate the total head movement, so it will be 53 minus 37 plus 37 minus 14 plus 14 minus 0 plus 65 minus 0 plus 67 minus 65 plus 98 minus 67 plus 122 minus 98 plus 124 minus 122 plus 183 minus 124. So when we will sum up this, then it will be the 208. So in this algorithm there will be the movement of 208 by the read write head. Next algorithm is the C-scan algorithm. C-scan disk scheduling is also known as the circular scan disk scheduling. In this case, let us understand the concept of this algorithm with the help of example. So again, this is the queue of input output request. This is current position, and suppose the read write head is moving in right direction. Here the direction of read write head is right. It means it is moving in the increasing order of track. Okay, so again what will happen, in which direction the read write head is moving, it will go to the end. It means it will go to the last track in that direction, and it will service all the requests coming in the path. So when the track read write head is track number 53, after that it will execute the 65, then 67, after that 98, 122, 124, 183. Okay, in this direction the highest request is 183, but it will go to the last track. Last track is 199. Again, when it's reached to the last track 199, then from here it will directly jump to the lower request. See here in the diagram, from 199 it will directly go to the 0, and when it will jump from higher from this end to this end, then it will not service the request coming in the path. For example, here it will not service the 37, it will not service the 14. Okay, it will directly go from 199 to 0, and after reaching to 0, after reaching to other end, it will change its direction and move in this direction, and then it will execute the remaining request. It means here it will execute the 14 and here it will execute the 37. So that is why this is known as the circular scan. So in case of circular scan, read write head moving in a particular direction, and it will service all the requests coming in the path, and it will reach to the end, and after reaching the end, it will directly jump to the other end of the disk, and it will change its direction, and after that it will service the remaining request. So this is the concept of the circular disk scheduling. Again, to calculate the total head movement, what we will do, 65 minus 53 plus 67 minus 65 plus 98 minus 67 plus 122 minus 98 plus 124 minus 122. So when we will sum up these slots distance, then total head movement will be calculated. Okay, next algorithm is the C-look algorithm. C-look algorithm is basically the version of C-scan. Let us understand with the help of this example. So this is the input output request, queue of input output request, current position is the 53. So in case of C-look algorithm, what will happen? Again, read write head is moving in right direction. Okay, so in which direction the read write head is moving, it will service all the requests coming in the path, and it will stop when the last input output request is serviced. Okay, it will not go to the end. This is the difference between the C scan and C look. At first it is current position is 53, then it will go to 65, execute 65. After that it will execute 67. After that it will execute 98, 122, 124, and it will reach the highest request, which is 183. Okay, so after reaching 183, it will change its direction and it will directly jump to the lower request, and the lower request is 14. It will not jump to the other end. So in case of C-look algorithm, there is not any kind of involvement of the outer side track or the inner side track. Okay, so the read write head moving in which direction, it will service all the requests coming in the path, and it will stop when it will service the highest request. After that it will directly jump to the lower request, and again it will change its direction, and now in this direction when it move, it will execute the remaining request. So in this direction the remaining request is 37. So now this at this time this will execute the 37. So this is the concept of the C-look disk scheduling algorithm. And to calculate the again total head movement, 65 minus 53 plus 67 minus 65 plus 98 minus 67 plus 122 minus 98 plus 124 minus 122 plus 183 minus 124 plus 183 minus 14 and 37 minus 14. So thank you. This is the concept of several type of disk scheduling algorithm we have seen in this lecture.